Welcome to Cross-Browser and Cross-Device Testing at Scale, part of our Applitools in Action webinar series. I'm Pam Morgan, and I will be the session host. I'm joined today by my colleague, Roy Friedman, a customer service manager here at Applitools. Roy has more than 20 years of experience in customer success, professional services, and delivery management across various industries. He's well-versed in the test automation domain and holds a degree in computer science from Technion, the Israel Institute of Technology.
Thanks. Thank you very much, Pam. And hello, everyone. Thanks for joining today's session on how to simplify your cross-browser and cross-testing efforts. Let's start. My name is Roy, as Pam said, and I'm an Applitools technical customer success manager for the past 2 years, which means that I help my customers to seamlessly and efficiently transition to a cross-platform testing using Applitools. Before that, let's talk about the problems and the challenges that we're facing as automation and quality engineers. With the growing complexity of UI systems, more devices that are used by your consumer, continuously testing across devices and browsers is obviously a must. Importantly, before the software is being released. However, with the desire to release much faster, some quality or efficiency impacts are sometimes overlooked, especially when using an outdated, cumbersome framework or ever-changing tool set and tech stack as part of your organization. We'll be touching this further, but before everything, I would like to start with a quick poll so I can get a better understanding on how you face the challenge of cross-browser, cross-platform testing in your organization. You should be able to see a poll right now. Yeah, great, thanks, Pam. And if you can click on the voting buttons, we can start collecting some of the results. Okay. Let's wait a few seconds. Great. Okay, so it's kind of an even distribution. I would say that the majority of the crowd uses either automating cross-platform using in-house homegrown development, and some are using cloud-based testing platforms. Okay, which makes sense to me. The thing is, and I can share it from my customers' experience, the cycle and the tedious process that starts when a test fails has many overheads involved. Okay, and this slide meant to give you a headache, right? So when a test fails, let's say on a pre-prod build running on a real device, could be several paths that we can take. First of all, we need to find a person or allocate the task of actually analyzing, getting access to the container, running the test, and understanding what the failure is all about. In relatively significant amount of cases, it will be just a broken test due to the cloud solution changes that have to do with the application under test. So there's no real bug here, but just additional effort and a velocity loss that is impacting the team. But let's say that the bug is found. And I know for a fact that these heavy lifts, test cycles to cover a wider set of devices and browsers are not usually done on an intraday basis, even not on a daily basis. Sometimes it takes weeks until a real and high coverage test cycle is being performed on the latest build. So we can talk about several commits that were already done to this branch that contained the issue that is related to the bug. A few pull requests has been already approved and merged into the main branch, and some time passes, 1 or even 2 sprints away since the bug was created. So now a developer has to stop his work, reduce the velocity of his current sprint, and start a learning curve to find out what the bug is and how to fix it. And sometimes a fix of this bug may introduce new bugs to other branches, other work streams, and that might break other tests. And we're back to square one. So what we really want to do is not only achieve 0 bugs in production, right? We want 0 bugs across all devices and browsers used by our consumers, and we want it during build time, because the faster, and this is industry numbers, the later the bug is found and fixed, the more costly it is to the organization. Okay? Did we really stop and try to measure these costs? Because on one hand, we invest a lot of effort, a lot of maintenance to keep our real device cloud solutions alive and running. And on the other hand, and you can change my mind that this is a statement that I can relate to, you don't have to agree, but I think that most bugs, okay, that are found may have a visual representation. Functional bugs or visual bugs will have a visual representation and are also likely to escape when using traditional automation approaches. So it doesn't matter if you executed the test on a real device, you can still lose and let a few bugs escape, and then finding them on manual testing really at the end of the cycle or before the production release. And we're talking a lot of cost that is impacting the organization because of that. For example, let's take a look at a traditional automation script trying to obtain a full UI coverage. It's almost impossible. Writing assertions on top of assertions in order to verify that your UI looks as it should will only result with more code that will require more maintenance, more flakiness of tests when elements change their location in the DOM, locators, CSS selectors are changing. So this is not the ideal approach to attend a visual validation, and of course not cross-browser and cross-device testing. With visual AI, it's basically the bread and butter solution called EYES. Applitools has been delivering it to our many customers for more than 10 years. We take a different approach to validate your UI. First of all, you don't need all this code. You remain with a single code assertion, a visual assertion that is not changing. You don't need to maintain it, and it is supported in a various SDKs and test frameworks, more than 50 that Applitools supports, and it provides the full coverage of the page, meaning once you run this command at any step in time in your test, you will know that the page, the tested screen or the tested page looks as it should, comparing to historical references and historical executions of this test. Visual AI ensures that you will find bugs and only bugs, meaning you will not be annoyed by dynamic content and differences that has to do with different browsers, browser versions, hardware that was executing the test. You only see differences that are visible to the human eye, and that holds a visual difference to the page. So the only thing you need to do is to add one simple visual assertion in your local test or your CI runs, and you discover bugs. But you not only discover them on your local machine, you discover them across all devices and all browsers. And how do we do that? Well, this very tiny and efficient command that I've shown before doesn't only capture the screen that is being presented by your WebDriver. What we do is something a bit more complicated. Basically, using any of our SDKs, we just send the complete DOM snapshot. We obtain the DOM snapshot of the pages it currently looks like, the screens it currently looks like in your driver, and we send it to our secured Ultrafast Grid cloud, where we have a lot of different machine, iOS devices that are rendering this DOM and making sure that visual regression is kept across all of these devices. We do it asynchronously, and we do it in parallel. So basically, your CI is not impacted. You don't need any resources from your organization. We do it for you and bring back the results to the SDK that is chosen in a format that is readable, traceable, and I will show how it looks like when you're analyzing the test results in our dashboard. So basically, it sounds simple, but there are several challenges that this is a very mature product that Applitools has been developing for several years now, and it's a very simple to describe it, but to the ability to support rendering of different and responsive DOM snapshots with complex CSS and dynamic CSS to stitch it into a one consistent single image that is comparable to its previous versions. It's not a lightweight task, and we're perfectly doing it. The maintenance and the ease of configuration that allows you to exactly decide which type of tests will run against which different devices, combinations of browsers, devices, and viewports is also achieved, in my opinion, at least, and to our customer satisfaction, to a level of just a few clicks of a button to extend, reduce, and achieve a wider coverage of devices and browsers. Also, in sense of maintenance, we're performing a lot of comparisons because we're matching your DOM, your pages on our premise to a wide set of different devices and browsers. What about test remediation, supporting changing UI? We don't want you to perform repetitive tasks in order to heal and maintain your test suites. We developed a mechanism that is called the auto maintenance mechanism that under the hood searches to perform additional actions, additional manual steps that are being triggered by yourself. So you click a button once to hint our solution on any remediation optimization to your test, and we will complete the task to all the other tests that failed with the similar difference, the similar issues. It minimizes your manual attention, manual labor significantly. Let's see it in action. Unless there are any questions that we would like to address now, I would be happy to present 3 real-world use cases that are successfully adopted by my customers, and I'll be happy to show them live and online. Now, please note that all the products that we will show now are easily accessible from in our website. Okay, you can create free trials, test it, and raise questions that will be addressed by our sales engineers. We're very responsive about it. So feel free to do that. I would like to take the first use case of an organization trying to test a full website. It could be a full website. It could be a web application with multi web pages, and the intention is to achieve a very quick win of performing tests across different devices and browsers with one click of a button. The second use case is, again, another codeless solution of ours that allows any organization that has minimal or not the capacity to invest development efforts into automating test flows, the ability to author in a self-healing, using plain English command, any custom test end-to-end to web application, and ensuring that each critical step of the test will be validated against a wide environments and a wide range of devices, browsers, different viewports. No line of code is needed here. And the third case is, let's say that your organization has a test automation project which is stable and healthy, and you would like to shift left and ensure that your UI is tested as part of your test automation project to the coverage that you require to provide your customers, not at the end of the life cycle, but even during unit testing. During unit testing, during the build time and the commit, you will be able to understand whether there is a visual impact to one of your UIs and screens on any exotic combination of device and browsers that you may imagine. So let's see it in action. This is autonomous, and it allows you to create a full website test. Sorry, let me cancel this one. It allows you to provide any URL. By the way, it could be your local host, it could be a local build, it could be an internal QA environment. It doesn't have to be publicly exposed because we have a secure tunnel that allows running WebDriver commands from within your domain, okay, to being sent to our infrastructure. So you can provide any URL here, define a list of any selection of environment on which you would like to test your pages, and by clicking next, let me just limit the amount of pages that we would like to scan. Autonomous will actively search for all the pages that are available in your on your website or your multi-web page application, and start creating baseline reference images that will be used in order to orchestrate consecutive and future runs to your website across any environment that you can think of. While this process happens, we also test for missing pages, HTTP errors that are coming from some of your pages, and also visual differences that requires attention. You could also test production to lower environments, UAT to Canary. It completely supports it, and our visual AI technology will ensure that you will not get false positives results due to dynamic content or any other changes that should not be considered as a visual bug, as a defect. Our customers are running thousands of tests on a daily basis with optimal pass rate of almost 100%, that allows them to scan across cross-platform other application pages and only attend a few numerous changes, remediate them, analyze them, maybe collaborate with the backend and front-end teams, while they get a very wide coverage of the rest of their application. I'm not going to stay for this to complete, as I have a result already. This is how a test suite that was executed by Autonomous looks like. You can see the different environments that were used as part of that were used to render some of the pages in the test. And under this screen, you can see issues and errors that were created as part of that were raised as part of the test. It could be a visual difference, missing pages, and at any point in time, you can define different environments on which you would like to, and you don't need any code skills, any understanding, any DevOps understanding in order to add an additional coordinate of testing. You would like to test increase the coverage of a specific test suite with a newer device, an old device, a legacy device that was used. We support -2 of every browser and a variety of probably all consumer devices that are available in the markets today. And you can just edit, and then you can define specific plans for different purposes, a daily one, an intraday build, a heavy lift test suite that runs on a monthly basis, and define specifically which environments your pages will be matched against. So once you're doing it, and when you get the results, you can browse all the screens that contain, you can first of all filter, group, and start analyzing which screens contained visual differences comparing to the historical executions of the same test. So on the right, you can always see the test being executed. To the left, the baseline that was used, and you can start analyzing the test. Let's at any point in time, you can accept, override, reject new baselines of the tested page. You don't need to manage files, image files. You don't deal with that at all. And you can always remediate and decide that a specific area in this tested screen should be treated with a different sensitivity of our algorithms, because we have several algorithms that might be in use. As I said, every step, every manual step that is being taken on the application will be applied to other steps if you choose to reduce the amount of time that you're spending on these repetitive tasks. So the auto maintenance always works behind the scenes. Now, there are no visual differences to the test, as I've instructed a specific part, a dynamic part of the test, to be treated with a more relaxed matching mechanism, to expect the pattern of a number, hour, minute here, but not to fail the test if the number differs. Of course, that we can select that the entire page will be executed on a different matching mechanism that is more relaxed or more strict. Okay. At any point in time, we can create an issue where the test failure could be also collaborated in Slack, in Teams. You can get a notification on visual testing failures. And we can even write a commit message to your version control or CI platform. So you don't really need to jump between different solutions in order to get visual testing results. Let's say that we want to, that we have a different use case, and we would like to actually author a new custom end-to-end test flow. We don't have the capacity to write code or to have an automation, or we don't have an automation environment to perform that. That's fine. Applitools has the capability of recording tests and creating test scenarios that are based on plain English commands that could be derived from your STP. Okay, to the right side, you see an interactive browser, which you can act on, okay, as any recording platform that you may be familiar with. The only change will be that we're not mimicking your mouse movements, your keyboard strike. We're actually understanding what you're trying to perform in this page, and we're parsing each instruction based on the page that currently is shown by the driver. So I want to type anything in search. Okay, it's happening. If you see it, then I want to hit enter. Okay, every command that was written here is self-healing in that sense that we will try to understand what element and what locator should be accessed as part of the command. We will show it to you and allow you to debug what was happening, what element was being manipulated as part of the test, and moreover, we allow you to perform non-visual assertions. So if we've talked so far about visual AI, our solution can allow you to basically write any command that in English that will make sense when looking at this page. Moreover, you can also perform API testing from this using this tool and use the response body, response object of these API calls, internal API calls of yours as part of the end-to-end flow and as part of the continuous test. But that's not what we wanted to talk about. At any point in time, you can perform you can add a visual assertion. And what happens here, once you're saving this test and binding it with any plan, every checkpoint or visual assertions that will be added here, we can add another one. Let me just drag it here. It will be matched against all the browsers, all the device viewports combinations that are part of your plan. So it's so easy to obtain full visual coverage and an immediate test that is being authored without any code involved. Looking at the third use case, if you really have a solution, I've chosen Playwright, okay, as a code example. If you really have a solution with fully working and stable tests that are implemented, in order to enrich your code, and that's the easiest part, in order to enrich your code and your test suites with full cross-platform validation, the only command that you'll have to put in Playwright, you'll have to install the ICE Playwright SDK, okay? And as you see here, we basically support almost any test framework that is in the market, okay? Both in sense of programming language or test framework. The only command that you have to put at any point in time where you will want to obtain a wide visual coverage is to add this simple command. Adding this simple command will pick up the DOM snapshot presented by the page at the moment, send it to our backend, and ensures that it's completely perfect comparing to past executions of the same test. In case there is a failure, we support and we respect any API, any test framework like Playwright, and we will communicate test results, fail the test according to the convention of the test framework that we're using. Where do you configure the different environments on which every visual assertion is being tested on? Very simple. You can do it using our UI, but you can also add a configuration code that defines specifically which type of browsers versions, viewports, and devices any visual assertion will be performed on. So this is how you tailor eyes to visually test your pages and tested screens. Of course, that we have mobile coverage, native mobile coverage as well across any different set of devices and browsers. You get these the test results, whether your page contains any visual difference that should be looked at directly to the test execution of this playwright suite with a deep link that shows you where it that takes you to the test results in order to analyze it, to remediate it. And of course, as I said, we have integrations with most CI platforms, version control repositories, and collaboration tools such as Teams and Slack, so you can get these results there. You don't have to be the automation developer in order to maintain the test. The developers can do one thing, while other personnel as part of the sprint can remediate the visual test results. I think this is a good time to stop for some questions and answers.
All right, we have a few questions from the audience. We will start with this. How does Applitools address the challenges of false positives or negatives in cross-browser visual testing, especially when minor rendering differences might be flagged as defects?
Okay, good question. I will refer to false positive first before I refer to false negatives. Basically, this is what Applitools, it's a good question because this is what Applitools is all about. The visual AI technology that we develop and which is trained on over more than 4 billion images along the years is trained to detect only differences that are visible to the human eye. This is how the AI is being trained. So it doesn't matter if the browser is rendering the page is in a different version, or is rendering it on a Windows machine with font smoothing on or off. We don't perform any naive pixel-to-pixel matching. We will only alert on changes that are visible to the human eye. And in sense of dynamic content, we have, for example, a match level that is called actually dynamic. Okay, it's exactly meant to face these challenges. So it will try to test the two images, the version that we hold as a baseline as the expected result, and the newly created checkpoint, the newly created test execution, and we will understand whether it has. We will do it mainly using computer vision, but also we will take some hints from the DOM. Having said that, we support everything I've just said. We support also for native mobile where we don't have a DOM, and we will understand which parts of the pages contains dynamic information, emails, pricing, e-commerce information, changing images. And because we have all the information of historical executions, we will only alert you whether there is a change that should be looked at. So it's what we do. Okay. Regarding false negatives, it's a lengthy answer. I think I will take it offline, and Pam, I will approach Jabalian in separate. I think we have time for one more question.
Okay. Flavio asks, the content of my app is sent from behind my firewall to the Applitools cloud, so it's not necessary for any visit from the Applitools software to my test environment.
Okay. Good question. Good question. I will not show it now, but using a secured tunnel, we basically allow you to install a tunnel, to download a tunnel client. This tunnel client, by the way, it's being used by heavily regulated financial institutions, and we passed that, so I'm almost sure that we can meet almost any security regulation and compliance requirements. We basically, you run the tunnel client from within your network. and you specify which host names. It could be local host, it could be your internal UAT or test environment, as you mentioned, and we execute the WebDriver commands from within your network, sending them securely out to the autonomous framework, where we basically act as if it was exposed, as if it was publicly exposed, and the only network is between point to point between our tunnel client that is running from within your network to the autonomous cloud. I have wide documentation that talks about security to our public cloud. If necessary, I'll be happy to share it with you, Flavio. And
Okay.
one more question.
I also mentioned that we can have one of our specialists follow up and to go through more detail with that. All right. Dan asked, so the mobile device testing is done only with emulators. There is no rendering on actual devices.
We render on emulators, Android devices, because it's relatively safe and much faster than running on real devices. For iOS, of course, that we use real devices. We use real devices for all of our Mac and iOS and Windows devices. So, and yeah, we use it's also shown in the, by the way, in the security document. But yeah, we do use emulators when we can, due to cost and efficiency reasons.
We also can have someone speak to you about partnerships that we have for real devices, if that's important. Would you like to do one more, Roy?
No, I have. Yeah, of course. As okay. Wikipedia is quite static. Yeah, please present the next one.
Okay.
If we didn't lose too much crowd already.
No, I think we're doing great.
Yeah, great.
Beyond says, as Wikipedia is quite static and simple, which is how do we better handle dynamic web pages, especially those which involve complex web elements, businesses, and workflows?
So I think we've answered this question before. I will show it. I will show it again. Let's go to one of our. Let's click the page and let's look at one of the tests that were failing. So. I'll go to the same example. We basically, in case you would like to, first of all, as a developer, if Beyond is a developer, we can. I didn't mention it, but as part of this code, the ICE check code, you can also hint and provide CSS selectors of elements that may contain, that may hold inside dynamic information. So as part of the ICE check command, you can already hint the algorithm to treat different parts of the screen with a more relaxed manner, and by that avoiding false positives. If, for example, this specific dashboard will contain amounts, prices that are changing, we will only ensure that the same UI standard is being kept, the same pattern. It contains a dollar sign with a number, which is a price. So we do that. We can understand whether the text is a price in a currency, whether it's date, and we are able to avoid whether it's like in e-commerce result pages that contain different items. We will. It's basically the AI magic that does that. So I cannot really explain it, but you can set up a trial account and see how it works with a real. I just chose Wikipedia for the purposes of the example because it's not blocking us. But you can test it using any website and see how it works. let me just show again that in our case, we can set in the code, so you don't have to be a developer, you can draw a region or select an element. Let's say this image might be changing. I can, or even might not be in the scope of my test. So whenever this element shows, I want to completely ignore it. Or I want to ignore pad and ignore the surrounding of it. Or I want to, and I know that it may float and appear in different places under this specific div, or completely ensure that it only keeps the pattern between the tested page and its preceding baseline. So it's completely controllable by the portal, by our dashboard, as it's controllable using our coded version of the SDK.
Thank you, everyone who joined us. And of course, thank you, Roy, for an excellent demonstration. As Roy mentioned, if we did not get to your question, or we will follow up with them. And if you have additional questions, you can schedule a call with one of our testing specialists to discuss your specific use case and or tech stack. There is a link on the chat, on the resources and on the resources tab. We hope you found today's session insightful. If you missed one of the other ones, including the test automation for dynamic applications, you can watch them on demand. They're all available at applitools.com/resources. As the pioneer and leader in AI-powered automated testing for the enterprise, Applitools aims to make intelligent solutions accessible to all and to deliver business value for our customers worldwide. If you're already using Applitools, reach out to your account team to learn more about how you can take advantage of some of these strategies Roy outlined today. And if you're not an Applitools customer, you can see firsthand the power of adding AI in every stage of your testing lifecycle by signing up for a free trial. There's a link below or on the resources tab. Thank you for joining us. We hope to see you again soon.